So last time we worked on solving equations with one step. And let's go and look at that. So our goal is to solve an equation. Solve an equation. And our goal in algebra is that we may see equations in a lot of different ways and to be prepared for that. It's almost like playing flashcards. I'm going to flash a card out and you have to quickly figure out what is the question freaking asking and then solve it as fast as you can. And that's the idea of algebra. Every problem could be different. We don't know what's going to come up next. And we want to be prepared for that because that's the SATs. SATs, every question could be different. We have to be able to sit there, analyze the situation, and then come up with a path to solve it. Every professional job does this. Think of a doctor. Who's going to come in the examination room next? I don't know. What's wrong with them? I don't know. So every problem is new and we have to critically think and then think of a pathway to help come up with a resolution. All right, so let's look at an old problem. If I say 3x is equal to 12, this is what we call a one step because there's only one thing wrong with it. So we mentioned before that my goal is to get x alone. We want x alone. So I labeled this with like numbers 1 and 2. So I'll say 1, identify which variable that you want to solve for. Okay, one step. So 1, identify variable. And then 2, identify ID, numbers to get rid of. Okay, and to get rid of these numbers, we said we're going to use the opposite operation, also called the inverse operation. So for 3x equals to 12, we identify 1, we want to solve for x. 2, we have to get rid of the 3, not the 12. Okay, 12 is already kicked out. He's outside the house already. We want to get rid of the 3. And so we say, what is 3 doing to x? 3 and x are multiplying each other. And the opposite of multiply, our inverse operation to multiply, is divide. So we divide both sides by 3. We do this particularly because 3 divided by 3 divide out, canceling each other out, essentially becoming just 1. And we mentioned before, do we really want to write 1x? We don't have to. We can just write this as a x equals to 12 divided by 3 is 4. Now, just aside, if you guys still don't know your multiplication tables really well, that's going to be a problem. Honestly, it's going to be a problem. So I highly recommend you download an app, a multiplication app, and you can actually test yourself right now. It'll take you 3 days. I promise you, it'll only take you 3 days, and you can learn all your multiplication tables up to 12. Download the app and just play on the app, and it'll just quiz you constantly, testing you, just like any video game that you played. And you can learn your multiplications in 3 days or less. Okay, so if you're not very good at them, I remember I struggled with 8 for a very long time. 8, that was kind of a tough one for me. I don't know why. Okay, all right, so that's our one-step equations. So we want to double check. 3 times 4 is equal to 12 because we said x was 4, now x became 4. That's what we're going to substitute. And then we're going to check. 3 times 4 is 12. We found the perfect match. Go get married. Yay. And our goal again is to find out what x is that would make the equation true. Okay, so let's go ahead and we'll go into our two-step problems now. So our two-step is 3x plus 2 is equal to 8. And now this is our multi-step. Multi-step. And in this case, this is going to be a two-step. Okay, two-step problem. Multi-step just meaning more than one. And this could be 3, 4, 5 steps. But this is going to be a simple two-step. And let's figure out why is this a simple two-step. Now, we're going to go through our process of thought. We said before, we're going to, step 1, identify what is my variable. This one is so obvious that it's just going to be x. That's my variable. process 2, is what do we have to get rid of so x can be alone? I need to get rid of the 3 and the 2. 8, we don't touch. 8, we already kicked out. So some kids, if you haven't been able to sort this out in your brain, you get confused about what numbers do we want to move and why don't we move that 8? It's because 8 is already on the other side of the equal sign. Remember, we're trying to get x alone. We're going to try to get x to look like x equals to our answer. We don't want anything around the x. Everyone needs to leave. This is my private time. Everyone get out. Okay? So we think of a strategy of how to solve for x, and there is an order of operations. Some people will say, hey, use PEMDAS. Remember PEMDAS, sorry. And that's please excuse my dear Aunt Sally, which is parentheses, exponents, multiplication, division, addition, and subtraction. And instead of going forward, we undo by going backwards. So instead of doing multiplication first, we actually do addition because we're working in the opposite direction. I find this sometimes confusing, but it's helpful to talk about it because some people will acknowledge that. If I just go backwards, do subtraction, addition first, then do multiplication, division, then do exponents, and then do parentheses. Sure, but I like using this slogan instead. Get rid of what's farthest away. Get rid of what's farthest away from your variable. So we've locked on target, stay on target. X is my variable. We decided for sure we have to get rid of the 3 and the 2. I want you guys to, right now, answer this quick poll. Which one do you think is farthest away? The 3 or the 2? So thank you. You guys said 2. So let's get rid of the 2. Now, to get rid of values, we use the opposite operation. So we minus 2 to both sides. Now, again, to repeat, oftentimes people write this because I don't know why. But remember, equal means whatever I do to one side, I must do to the other. Right? Your mom says, I love you guys equally. We know that was completely a lie. But if I give my son $5, I must give my daughter $5. If I really believe I love them equally, I don't. Shoot, this is being recorded. Okay. So I'm going to fix that. I want to minus 2 to both sides. 3x. My son's going to find this YouTube later, like 10 years later. He's going to say, you said you don't love us equally. Okay. All right. Now we went from a 2-step equation to a 1-step equation. And this is the cool thing about math. It becomes easier. And not only does it become easier, it goes back to things that we've practiced before. And if we're good with 1 step, you know what? We're going from 2 steps back to 1 step. Our next move is opposite of multiply by 3 is to divide by 3 to both sides. And some of you guys have built that intuition already. You've done enough practice problems that it's muscle memory. I know I'm going to get rid of the 3. Opposite of multiplication is division. Just to re-stress that every time a number and a letter are next to each other, it's always multiplication. Now, math people are pretty efficient people. If I write x cubed like this isn't multiplication, this is exponents. This is powers. Okay? And there's a big difference. One is it's an upper right-hand corner versus being in front. You guys have been taught already not to write numbers in the back. We don't write x3. Though this isn't necessarily wrong, it is confusing for most of us with bad handwriting. If you had bad handwriting and you just wrote the x just a little bit smaller like that, you would think this is x cubed. That's why we don't write numbers in the back. We always write them in the front. Our constants, our coefficients are always written in the front. If you want to write in the back, to clear up the confusion, we must write it as this. Writing it with the parentheses definitely makes it less confusing. But I think, and the convention is, that we always stick to this one. This is the one we use. Number in front and a variable means multiplication. Whenever you see a number in front and a variable, it is always multiplication. Great. So let's go ahead and continue with this multi-step equation idea. So let's do one more problem. Wait, let me pause for a moment. So let's go ahead and make the problem a little more difficult. Instead of a 3 for multiplication, we're going to rewrite the example as x over 3 plus 2 is equal to, let's do 6. Okay, this problem is slightly different. We're going to follow all the same procedures as before. Our thought process are going to be exactly the same. First step, what is the variable? What am I trying to isolate? First step is 1 is x. We need to get x by itself. X is having a bad day. Please give x some space. 2, we want to decide what numbers we want to get rid of. We want to get rid of the 3 and the 2. We don't want to get rid of the 6. This is cool. We're cool. He's already on the outside. Okay, he's already on the other side of the equal sign. Again, these thought processes have to be taught. We have to realize, why do we not mess with the 6? Why do we want to get rid of only the 3 and the 2? And it's something that we have to talk about. Okay? Now that we're here, what number do you get rid of first? Give me a sec. I'm going to go ahead and try this poll again. So we want to get rid of the 2 first. The opposite of plus 2 is minus 2. Rewriting this as x over 3 is equal to 4, because the plus 2 minus 2 subtracted out. Now again, you guys could write this. This is actually totally legit. Plus 0, but why, right? But why? Because 0 is not going to add anything to it. So what we do is we skip a step and we just go ahead and write it nicely without the 0 there. Okay. What is 100 plus 0? Just 100. Why'd you have to bring that up? Okay. Next step, we want to solve for x again, identifying in our brains that, hey, I'm still solving for x, but I have to get rid of 2 now. How do I get rid of get rid of 3 now? How do I get rid of divide by 3? Opposite operation of divide by 3 is multiply by 3. And we talked about this last time, is I can write the times 3 in the parentheses on either side, and that would be okay. If you want to write it as x over 3, and you want to squeeze in the times 3 on the right side, that is perfectly fine. That is okay. But I find it's easier to just write it on the left side. Now, just to reiterate this, what is 3 divided by 3? 3 divided by 3 is 1. And if I want to write 1x is the same as x. So to save time, instead of writing 1x, we're just going to write x is equal to 4 times 3 is 12. Now, I honestly wouldn't have guessed 12 if I was just given this question right away. But that's why we have this order, this process to solve for variables. Because as problems get more difficult, we can have more tools, and we know a specific process by which we can solve these more difficult problems. Okay, so let's double check. 12 over 3 plus 2 is equal to 6, okay? I'm plugging in the x into the question to just double check to make sure we're on the same page here. So 12 divided by 3 is 4. 4 plus 2 is a 6. Again, if you're struggling with multiplication and division, I can't stress, go download an app. There are dozens of apps out there. One of them is even called Ninja Multiplication. And you're like the ninja, okay, doing multiplication. So if you're not good with your multiplication tables, go download an app, and we're good. Okay, so I'm going to make this, in the next step, a little more trippy. So I'm going to write 6 minus 3 x is equal to, let's do 3. Okay. So this is my next problem. We're going to go through our steps for solving the problem again. 1, identify the variable. Okay, I see x, that's the variable we want to solve for. And I want to identify what numbers I have to get rid of. I see it's a 2 and a 3. We want to make sure we know which one is farthest away. Do I get rid of the 6 or the 3? And the way my logic goes is, imagine if you were in a room, okay, and we have a 6 and a 3x, and here's the door. And outside the door, there's a 3, okay? So who can you get rid of first? Who do you have the stronger ability to get rid of? The person right next to you or the person farthest away? I always think of it as get rid of the person farthest away from you. So I'm going to say, hey, 6, get out. If you try to get 3 to get out, 3 would have to fight the 6 to get out. It's going to have to push itself out of the room. So the idea here is get rid of the number that's not multiplying or dividing first, the one that's farthest away. And in this case, it's going to be the 6. So the opposite of plus 6 is a minus 6 to both sides. We're left with a negative 3x is equal to negative 3. Just as a reminder, there are more negatives than positives, so the answer will be negative. You have $3, you owe 6, well, you still owe $3. Okay. Our next move, now we have a negative 3. The opposite of, so I want to remind you guys, what is negative 3 doing to the x? Adding, subtracting, multiplying, or dividing. Whenever you see a number and a variable next to each other, we mentioned this before, number and variable, it's always going to be multiplication. Number variables will always be multiplication. They're multiplying each other. So the opposite of a multiply is a divide. So we're going to divide both sides by a negative 3. Take your trash out with you when you leave. That negative sign is almost like it's trash. Take it out with you. Don't leave it here. I don't want it. And a negative divided by negative becomes a positive. Let's take a look at that. That divides out. Let me go ahead and write on the side. Negative 3. Oops. Negative 3 over negative 3. How many times does negative 3 go into negative 3? That's exactly 1. And that's going to be for us a positive 1. Or you consider a negative and negative become a positive. And then a 3 then divided by 3 is a 1. So we have an x, 1x, and 3 divided by 3, negative, negative is a positive 1. Now, negatives can be confusing, but with enough practice, they clear up. And if we don't practice enough, of course, it's going to stay confusing. If you get stuck on a negative question, please make sure you ask. Your brain is asking, is struggling to get the answer. So answer that question. Get clarification. 6 minus 3 is the 3 we wanted. Okay, 6 minus 3 gives us the 3 we wanted. Let's see. Do you guys have any other questions about these types of problems? I want to pause the video here. Okay, let's just do one more problem here. And the problem's going to look like this. 2x plus 3 over 4 is equal to wait, let me change one of these numbers. I'm gonna change this to a 5. Sorry, change this to a 5. Equals to 3. Okay. Here's my next example. Now, we're going to follow all the steps that we did before. We're going to, 1, identify the variable. 1, identify the variable. We know it's going to be x. 2, identify all the numbers I need to get rid of. I need to get rid of the 2. I need to get rid of the 3. And I need to get rid of the 5. Now for this problem, I'm going to write this in a weird, like, matrix way. Well, not like a math matrix, but I'm going to rewrite this with a bunch of parentheses. So here we go. X, I am alone. Okay? And then the next thing I have to attach to it is the 2. 2 times x. Okay? You see the process? Next thing I have to do is divide the 5 or plus the 3. I need to plus the 3 next. Plus the 3. And to all this, I divide the 5. If I drew out every problem in this onion style, think of this as an onion. Think of this as an onion, okay? What would be my outermost peel? Then followed by what number would be next? And then what would my last number be? Looking at it this way, what would be the number that's farthest away outside the force field of x? So take a moment, look at it. I'm going to set up a poll. Okay, which one would it be? 2, 3, or 5? Okay, be 2, 3, or 5. Which of these would be the farthest away from the x? Looking at it as an onion. Look at the right side. Which of these do you think it would be? Okay. Okay, go ahead and make a guess on the poll. 2, 3, or 5. Which of these would be the farthest away from my x? Okay, 20-second poll done. Let's share the results. And we actually have a mixed bag. A lot of you guys said 3, and a lot of you guys said 5. And only a few of you guys said 2. But I want you guys to look at this again. Isn't x buried really deep inside the problem? So I don't want to get rid of the 2. 2 is right next to the x. And isn't 3 inside this big parentheses here? So which of these is on the farthest level? It's actually the 5. If you look here, it's going to be 2x plus 3 is one group. And 5 is actually outside that group. So when it comes to opposite operations, we want to get rid of stuff that's outside, most farthest away from that group. And in this case, it's actually going to be the 5. So to get rid of the divide by 5, we would multiply 5 to both sides. So let's rewrite this again to make it look all pretty. So 2x plus 3 over 5 is equal to 2. We would multiply both sides by 5 first. Now, why would we do this? If I asked you guys, and some of you guys said get rid of the 3 first, let me show you guys what would happen if I get rid of the 3. 2x plus 3 over 5 minus 3. Can you even combine the 3 and the fraction? Do you see how it looks really ugly? And that's why we want to be careful about it. And we practice this, not that we already know it, but we practice it so we don't end up making the same mistake. So what happens is, I can't get rid of the 3 because of that stupid fraction. It's going to mess me up. So let's get rid of the fraction first. So if I look here, the 5 and 5, see how they divide out? Because 5 divided by 5. And then we're left with a nice 2x plus 3 is equal to 10. Now from here, what number do I get rid of next? Let's set up the quick poll again. Do I get rid of the 2 or 3 here? Okay, 20-second poll done. Share results. So many of you guys chose 3. Some of you guys still chose 5, even though there's no 5 here anymore. But some of you guys still chose 2, which is fine. So let's take a look. Which one is farthest away from the x. So if we're deciding to solve for x again, see, I want you guys to please take note that the 2 is bonded with the x through multiplication, and the 3 is our free floater. We can get rid of our weakest link. You are the weakest link. You're fired, right? You're the weakest link here. So we can minus that 3 easily. Now to play devil's advocate, if I write 2x plus 3, and you might say, Mishko, we want to get rid of the 2, divide by 2. Remember, the equal sign says we have to divide everyone by 2. Do you want to divide 3 by 2? We can't, right? We don't know what that is. So this actually makes it even more difficult. You cannot just divide the front. You have to divide everybody. And that's the idea of opposite operations with equals. We're doing the whole process to everyone on that side. We're left with 2x equals to 7. Wait, whoops, did I do that right? Oh yeah, whoops. Oh, I know my mistake. Ash! I copied that wrong. Isn't this supposed to be a 3 and a 2? Dang it. That's what I was like wondering why the answer didn't come out. So this is supposed to be a 3. Please change this to a 3 because I copied it wrong. And then change this to a 15. Everyone change this to a 15, please, because I copied it wrong. Again, a doofus. Okay, 15. And that becomes a 12. So please change those values. Make sure you change this and this here. My last step. Now we can get rid of the 2 easily. Divide by 2 to both sides. X is equal to 6. Okay, I'm going to double check this question right from the top. Does 2 times 6 plus 3 over 5, does that equal to 3? That is my ultimate question. Does me choosing x is 6 give me an equivalent statement? 12 plus 3 over 5 is the same as 15. 12 plus 3 is 15 over 5, and that's 3. And yep, they are equal. Okay, so let me stop here and